Start. So where did we stop in the last class? As you people know, we were talking about the collection API. In the collection API, especially, we were talking about the collection interface. We got an interface called as collection, right? So we were talking about that interface in the last class. Here, in the collection interface, okay, we had methods. So we were talking about those methods. So we have gone through methods like size, isempty, contains, to array, add, remove, contains all, add all, remove all, retain all, clear. So these are the methods which I have discussed. So today, first of all, I'll talk about this iterator. Okay. So we got a method uh, known as iterator. Okay. So we'll talk about this iterator method. Yes. So how did we read the elements from the collections? How did we read the elements from the collections? Yes. Yes. So how did we read the elements from the collections? Uh, we have used for each method, sorry, for each loop, reading the elements from the collections. I'm talking about reading. How did we read the elements from the collections? How did we read the elements from the collections? So we have used for each loop for that purpose, right? To be more specific, reading all the elements from the collection. How did we read all the elements from the collection here? So for that, we have used for each loop. You people know that. But here we got another method which we can use to read the elements from the collections. So what is that method? That method is, sorry, not method. We got an interface altogether, I can say. We got an interface to read the elements from the collection. It is actually called as iterator. Just a minute. Iterator. So what is it? Iterator is an interface. So basically, this iterator interface has got methods like has next and next methods which we can use to read the elements from the collections. Okay, we can use this has next and next methods here. Here, first of all, if you want to use these methods which are defined in this iterator, you need to obtain the iterator object reference. You need to obtain iterator object reference. You see, for that we got this method called as iterator. In the collection interface, you'll find a method called as iterator. Okay, yes. See that method return type. What is the return type of this method? What it returns? Yes, it returns an iterator object reference. But I said iterator is an interface, right? It returns the object reference of the class which implements iterator interface. It returns the object reference of the class which implements that iterator interface, I can say. You know, here we can use that object reference to read the elements. So let's try to do that now. You see, first of all, I'll obtain that iterator object reference. You see this way. Now once you got this iterator object reference, you see, we can use it to read the elements from the collection. Okay, yes. So first I'll write this code and then I'll explain it. Okay. You see here, these two methods has next and next. They are actually defined here in your iterator interface, as I told you people. Now let's see how it helps to read those methods. Sorry, to read the elements. So let's say you got the elements this way. Just a minute. Harry, Raj and Kumar. Okay. So these are the three elements which you got here. So we'll obtain this iterator object reference. We'll obtain the iterator object reference, right? Once you do that, in the iterator you'll find that you'll have a cursor. In the iterator, you'll find that you'll have a cursor. So that cursor, it is initially placed before the first element. It is initially placed before the first element. Just a second. So sorry, yeah, I'm back. So it is initially placed before the first element. Okay. Now here we got this has next method. You see, when you call this has next method, so what it does is it will check whether there is any element after the cursor. So is there any element after the cursor? I can say yes. So has next method returns true. So once has next method returns true, you see, the control enters into the loop. Always has next method returns a boolean value, either true or false. So if it finds an element after the cursor, it returns true. Otherwise, it returns false. So in this case, you see, it returns true. So the control enters into the loop. You see, in the loop, now we have this code. What is it? I'll tell you. I say if you want to read that element which is placed after the cursor, so you need to call next method. If you want to read the element which is placed after the cursor, then you need to call next method here. When you call the next method, what happens? So first of all, the element which is placed after the cursor will be written. The element which is placed after the cursor will be written. So what is that element? You got Harry. So that element will be written. And one more thing happens here. So the cursor here will be placed after that element which is written. So which element is written? Harry. Now the cursor will be placed after the element which is written. So which element is written? Harry is written. So cursor is placed after that element now. Okay, yes. Now you see, that is what we are doing. So we are calling next method, it returns an element and we are storing it into this variable. We are storing it into this variable here. That's it. Okay. Now after reading that element, so you are printing it, and then again we'll call next. This is a while loop, right? Again the next method, has next method will be called. Again the has next method is called. So when the has next method is called, so again it will check whether there is any element after the cursor. Yes. So is there any element after the cursor? Yes, there is an element. So has next method returns true. So once it returns true, the control enters into the loop. And you see here, what happens? We'll call the next method here. So when we call the next method, what happens? Again, it will read the element which is placed after the cursor. This time Raj will be read and it will be written, and the cursor will be placed after that element Raj. That's it. And you see we'll get that element here. So we'll use it in the loop. And then again has next method is called. Again the same story repeats. Again the next method will be invoked. Now you see, let's say we have read all the elements. So the cursor is placed after the last element here. The cursor is placed after the last element. So now this time if we call has next method, so what it does, again it will check whether there is any element after the cursor. So is there any element after the cursor? I can say no. So there is no element after the cursor, so it returns false. This time has next method returns false. That's it. So that is how it works. So let me run this code. You see you got the elements. So this way we can use an iterator to read the elements. So is it clear for you people? All of you, can I have yes or no? Is it clear? Any questions? Okay. So can I assume that this is clear? Fine. So let's move on. So we got two options now to read the elements. One is for each loop and the other one is iterator. You know, for each loop was added in Java 5. So prior to Java 5, so we didn't had that for each loop. Okay. Yeah. Okay. Next we'll move on. Now we got this methods like remove if, as I told you people, split iterator and a stream parallel stream. So they are introduced in Java 8. So I will talk about this Java 8 features later on. Okay. Yes. So Java is recently released. Yes. So this is about the collection interface. Now hope you understood that this methods which you got in the collection interface so far, which we have discussed. So they are the most common operations which we perform on the collections, right? Yes. So now let's move on. Here I'm going to talk about the collection class hierarchy. So at the root of the collection class hierarchy, you got that collection interface. Okay. At the root of the collection class hierarchy, we got the collection interface. So, but there are sub interfaces for the collection interface. So you'll find list and set interfaces. Okay. Yes. You'll find list and set interfaces. Yes. So list and set interfaces basically they extend collection interface. List and set interfaces, they both extend collection interface. They are sub interfaces of collection interface, I can say. You know, here list interface represents one type of collections and set interface represents another type of collections. So is anyone familiar with the differences between list and set type collections? Yes. So is anyone familiar with the differences between list and set type collections? No? So you'll find that, okay, I got some answers. Let me see. Good to see your answers. Okay. Set does not doesn't allow duplicate values. Okay. Set will not allow duplicate values. Whereas list are unidirectional. Okay. Non-indexed. Okay. Sets can be branch of. Okay. Yeah. So you people are right. So you'll find that list type collections can allow duplicates. Already we saw that in the last class. Okay. Whereas list sorry, list allows duplicates, right? Whereas what about set here? Set, it won't allow duplicates. Set is a collection of unique elements always. List is indexed based. The elements in the list type collections, you'll find that most of the times you'll have index. When we talk about set, set type collections are not index based. Set type collections, they're not indexed based. Okay. So you see, you'll find that list interface inherits all the methods from the collection interface. But additionally again, in the list interface, we got some methods. Okay, so let's go through that list methods. What are the methods here in the list interface? These two interfaces, they represent two different types of collections here. Yes. Most of the methods you will find that here they are from list interface, but additionally you should see this methods like get, set. So, so these are the methods which are particularly defined in the list interface. You know, this get method, when you call this get method, what it does is it returns the Unicode value. Sorry, when you call the get method, generally get method is used to read an element based on the index. Get method is used to read an element based on the index. Okay, so get method, what it does is it takes the index and returns the element which is at that particular index. Yes. So that is how the get method works. Get method, what it does, it will take the index of an element and returns the element which is at that particular index. So for example, you got these elements now. See, we have added them to this list, linked list. So linked list is one type of list collection. Okay. So the first element which you'll add, it will be at index 1, second one at index, sorry, first one at index 0, second one at index 1, third one at index 2. Here, now I want to read the element which is at index 1. So I can use that get method now. See, names dot get 1. Now you might be wondering, actually, so the methods are defined in the list interface, but you see the class which you're using is linked list, right? So if you keenly observe in the hierarchy, you'll find that so linked list will be implementing the list interface. Okay. So now you see get method will take that index and returns element at index 1. Yeah. So let's run this code. So you got this element Raj. Yes. Okay. Next, we got set method. You see, set method, it is used to add an element at a specified index. If you want to add an element at a specified index, then you can use set method. You see, the set method it takes two parameters. So the first parameter is the index. Okay. So at which index you want to add that element, and the second parameter is the element itself which you want to add. The second parameter is the element which you want to add here. Yes. So let's see here. For suppose I want to add the element at index 1. So I'll call the set method and pass the index as 1. Say what element you want to add at this index. Let's say John. Okay. So, okay. Now this element will be added at index 1. So which element? John. But now the question is, what about the element which is already at index 1? What about the element which is already at index 1? What do you people think? Already there is an element at index 1, right? So what happens to that element? Yes. Uh, Actually, if you use set method, so that element will be completely replaced. It is not retained. Okay. So that element will not be retained. Okay. So it is replaced with a new element. So let's try to run this code. So after adding the element, so we'll try to read the elements. Okay. So we'll try to read the elements here. Yes. You see, now you got John. Raj is replaced completely. Okay. So next we got add method. Add method is also similar to set method, which we saw now. So add method, it is also used to add an element at a specified index. Add method is used to add an element at a specified index. The difference is, so add method will retain the existing element, unlike set method. Add method, it will retain the existing element. It will move it to the next index. Okay, so it will move it to the next index here. You see, I'll use add method this time. Again, I'm trying to add an element at index 1. You see, to that add method, the first parameter which you're passing is that index, and the second parameter is the element itself. Now, what happens to this element which is at index 1 already? It will be moved to index 2. It will be moved to index 2. Yes. Now, the element which is at index 2 will be moved to index 3, and so on like that. That's it. See? Okay. So this is about add. Next we got remove. Already we saw a remove method in the collection interface. Now, how is this method different from the collection interface remove method? Can you people tell me? So yeah, you will find that the remove method of the collection interface, what it does is it takes an element and removes that element. Okay. Next, here in the list interface, the method which you got, the remove method, what it does is it takes the index of that element. It takes the index of the element and it removes it. That is the main difference. Okay. Remove method here, it takes the index of that element and removes it, and yes, it returns that element which is removed. Whereas the remove method which you got in the collection interface, it takes the element itself and it removes it. Okay, that's the difference. Next, we got index of method here. Index of. See, the index of method, what it does is it will take an element and returns the index of that element. It will take the element and returns the index of that element here. Next, we got last index of. Okay, just a second. Sorry. Last index of. For suppose here, let's say you got the elements this way. Okay. You see that element Raj, it repeats twice. It is duplicated here. So if you call index of and pass the element Raj, then it returns which index, 1 or 3? Yeah, it returns 1 itself, okay? Index of method returns 1. But what if use last index of method, let's see. Yes, names dot last index of pass the element, let's say Raj. This time what it does, it returns 3. Okay, it returns 3. In case of index of, it returns 1, whereas last index of, it returns the index of the element which occurs at the last, you know. I mean, it takes only the last occurrence of that element. So last, at last, where it occurs, this element at index 3, right? Yes, not the first occurrence. So index of method returns the first occurrence of that element, whereas last index of method returns the last occurrence of that element. Yeah. Okay. You see, it should return 3 here. Okay. Next, we got list iterator. You know, list iterator, you'll find that it extends iterator interface. You see, just now we have gone through iterator interface, right? So why did we use iterator interface? Yes, why did we use iterator interface? To read the elements from the collection, right? We use iterator interface to read the elements from the collection. Whereas list iterator is also used for the same purpose, to read the elements from the collection. Yes, list iterator is also used to read the elements. List iterator also does the same thing. It extends iterator interface. Okay. But now you people just read the methods and try to understand what is the difference between iterator and list iterator. So if you want, I'll show you people iterator methods as well. Can you figure it out? What is the difference exactly between list iterator and iterator? List iterator also is used to read the elements from the collection. Just check once. Yeah. What's the difference? Okay, we can't add the elements through the iterator. That's right, I do agree. Good. And there is one more difference. You know what? You'll find this methods has previous methods. Did you notice it? They're exactly opposite to has next and next methods. And one more thing, we got the methods to find out the index which is placed on index of the element which is placed after the cursor. You can find out the index of the element which is placed after the cursor. Okay, that is the main difference. Yes. So has previous and previous. You see, for suppose I'll do this. Shall call next method. Sorry, just a minute. Shall obtain list iterator object. How? Using that method list iterator. Okay, list iterator. It returns list iterator object reference. Okay. Now I'll call iterator dot next. If I call iterator dot next, so the cursor will be here after the first element. You know that. Now, if I call has previous method, can someone explain me what it does? The has previous method. If I call that method, what exactly it does? If I call has previous method here in this case, what it returns, true or false, and what exactly it will check for. You can unmute and talk to me, because the answers are lengthy, right? So has previous will check whether there is any element placed before the cursor. So is there any element placed before the cursor here? Yes, we got that element Harry. So it returns true. Has previous method returns true. Yes. Okay. Yeah. Now, what if I call previous method what it returns? I'll do this. Iterator dot previous. Now in this case, what exactly happens? What will be printed? So it should return Harry. Yes. It will return Harry. It prints Harry here, and the cursor also will be placed here before that element Harry now. The cursor's position also changes. Okay. So let's run this code. So it prints Harry. Yes. Okay. Any questions? I hope no, right? Fine. Now you got next index of method. Now next index of method, what it does is it returns the index of the element which is placed after the cursor. It returns the index of the element which is placed after the cursor. Okay. Yes. So for suppose here, after calling next method, if I call next index of next index, then what happens? After calling next, you see where the cursor will be here. Okay. Yes. Yeah. So if I call next index method, what it does, what it is going to return in this case, what it should return. So it returns 1. It should return the index is 1. You see, it will next index method will return the index of the element which is placed after the cursor, right? It returns 1. Okay. Next, similarly, we got previous index of method, here in the list iterator. So what it does, it returns the index of the element which is placed before the cursor. Previous index of method returns the element which is placed before the cursor. So which element is placed before the cursor? It returns the index of that element. So you see, before the cursor you have that Harry whose index is 0. You see, if I call previous index of method, it should return 0 here. Okay. Next, we got remove method which will remove the element placed after the cursor. So set method, what it does, it will add a new element. So it will replace an existing element which is placed after the cursor with this new element here. Set method will replace a new element with the existing element which is placed after the cursor. Yes. Similarly, add method, it won't replace it. Okay, it will add a new element after the cursor, but the existing element will be moved to the next index. That's it. So these are the methods of the list iterator. So is it clear for you people, all of you? Okay, good. So now let's move on. We'll go back to that list interface. Now, sorry, we were talking about this list iterator. We got sublist here. Sublist. If you want to read part of a list, then you can use sublist method. Now what I'll do is here, I'll call sublist method and pass 1 and 3. You know, now it returns a sublist, I can say. We'll get a sublist with what elements? You'll get 1 because you have specified the index is 1. You'll get 2 as well, not 3. You mentioned 3 here. 1 comma 3 means the elements between 1 and 3, including 1 but not 3. Okay, it reads the elements between 1 and 3, including 1 but not 3. So let's read the elements here using for each loop. So it should print Raj Kumar, that's it. Okay, this is how the sublist method works. Okay, so these are the methods which I can say which you got here. Okay, now I can say that the methods which we got in the list interface, especially the methods which you got here in the list interface, there is something special about this methods. What is it? The methods which you got here in the list interface. So there is something special about it. What is it? What is special about all these methods? Yes. Do you see anything special or common between all these methods? There is something common between these methods. What is it? Uh, of course, this is an interface. They'll be abstract. Yes, I do agree, but that is not the case. Um, Fine. So, do you see anything else common here between these methods? Operation wise, let me give you people a hint. Okay, yeah, you're close. You're close. Be more specific. I can say all these methods are basically indexed based operations. All these methods, they're based on indexed based operations. Am I right? You got indexed based operations here. You got that, all of you. So get method takes an index, returns the element. Set method takes an index, adds the element at that index. Add method also the same. Remove method takes an element and remove index. I'm sorry. Remove method takes the index and removes the element at that index. Index of method also takes the element. It returns the index of that element. Last index of it. Also based on the index. Even in list iterator, you see the methods, the traditional methods which you got, they are index based. You got the point, all of you? Yes. That's it. This is about list interface. Okay. Now let's move on. Here we got several collection classes here which implement this list interface. So here the various collection classes are array list, linker list, vector, stack. Okay. So we'll start with this array list. You see, we have used array list, but we didn't dig into the details, especially the data structure. Array list class is one of the collection classes here. You'll find that ArrayList class implements ArrayList data structure. This is the same data structure which is used in the arrays as well. List data structure, or you can say ArrayList data structure. I can say you people are familiar with this data structure. You know the elements in this data structure, they're stored based on the index value. So let's have a look into this once quickly. So you people are familiar though. You see on top, don't worry about the data structure which you got at the bottom. It is linked list. Just look at the top here. On top you have this array list. You see it is index based, especially the elements are placed one after the other based on the index. Yes, starts with 0, 1, 2, 3, and so on. Here the list data structure, or LA list data structure, I can say that it supports random access. I can say it supports random access. Yeah, okay. Just a minute, please. Just a minute. Yeah, I'm sorry. So you know, ArrayList actually it supports random access. What is random access? Anyone got any idea about it? Random access. Random access. I really supports random access. Yes, random access means. Did anyone answer? Give me a sec. Let me just get me some. Let me get some water. Okay, just a second, please. Yeah, sorry. So hope you people can hear me, right? So both read and write is called random access. Huh? No, let me explain it. You know, random access means given the index of the element, given the index of an element, you know, straight away we can browse to that element. We can read the element. Given the index of the element, we can browse to that element and we can read the element. Okay. Yes. Okay. Random access means given the index of an element straight away, we can browse to that element and read the element which is at that specified index. That's it. Okay. That is how array list works. Now you see if you consider this example here, which you got, index starts with 0 and the last index is 99. That means uh, how many elements we got here? 100 elements in this list, right? We got 100 elements in this list here. Yes. You see, you will find that uh, if you want to remove the element at a specified index, we can do that here in this array list. You see, for example, I want to not remove, I'm sorry, I want to add an element. We can do that. We can add an element at a specified index, you know that, right? For example, here, I want to add the index at, sorry, add an element at index 1. Just assume that we got the elements from 0 to 99. Already we got the elements from 0 to 99. That means we got 100 elements here. Okay. Now what I want to do is here, I would like to add the element at index 1. So I'm using add method, let's say. That means how many elements are we supposed to move here? Yes. How many elements are we supposed to move? 3? No, not 3. How many elements we are supposed to move if we want to add the element at index 1? Yes, we need to move 99, not even 98. 99 elements have to be moved, right? From index 1 to 99. So all the 99 elements have to be moved. So you got this, all of you? Yes? Yeah. Okay. So don't you think, can I say that, I'm sorry, can I say that this is an overhead adding the element here to the list here? Can I say it is an overhead? Can I say we got an overhead of moving the elements in this case? I can say yes, right? We got an overhead here of moving the elements. Yeah. Okay, we have to move the elements. Even in case of deleting also, if you delete an element at index 1, again all the elements have to be moved. So this is how list works. Okay. So the array list class basically it implements that list itself. So if you want to store the elements, okay, into a list data structure, or in other words, a array list data structure, you have to use array list class here. Okay, this is the class. Now, have you noticed the beauty of this API? You will find that all the collection classes have got the common methods, right? Which helps us to easily work with this collection. Okay, so now we got another class called as vector. So vector class also implements array list data structure. Okay, please make a note of it. Vector class also implements array list data structure. Yes. Okay, then what is the difference between ArrayList and vector? If both the classes implement the same data structure, what is the difference? You can say that, first of all, the main difference. Just listen to me and then you can later make a note of it. I'll dictate it. Vector class objects are thread safe. Vector class objects are thread safe. Thread safe. And how about ArrayList class? ArrayList class objects are not thread safe. This is one of the most important difference between ArrayList and vector. Okay, this is the most important difference between ArrayList and vector. Now you can make a note of it, please. So you can have it ArrayList versus vector. So vector objects are thread safe. Vector class objects are thread safe. Okay, vector class objects are thread safe, whereas ArrayList class objects are not thread safe. ArrayList class objects are not thread safe. Okay. So what do we mean by thread safe object here? When I say vector objects are thread safe or array list objects are thread safe, what does that mean? You'll find that if an object is thread safe, if an object is thread safe, at any given point of time, only one thread can operate on that object. If an object is thread safe, at any given point of time, only one thread can operate on that object. Okay, please make a note of it. Thread safe object means at any given point of time, only one thread can operate on a thread safe object. Only one thread can operate on a thread safe object. Okay, at any given point of time, only one thread can operate on a thread safe object. Yes. So this concept is actually related to synchronization. It's a synchronization. Okay. Yes. Okay. Fine. You'll come to know more about this thread safe concept and the synchronization in the thread programming. Okay. Yes. So people also tell you will give you another difference here. What is it? Just make a note of it. Vector class was introduced in earlier versions of Java. Vector class was introduced in earlier versions of Java. Okay, vector class was introduced in earlier versions of Java. Whereas ArrayList class was introduced in later versions of Java. ArrayList class was introduced in later versions of Java. Okay, ArrayList class was introduced in later versions of Java. Yes, that is the main difference between ArrayList and vector classes. Okay, vector is a legacy class. So now let's go through the methods of the vector. So you'll find one thing, a new keyword here. What is it? Can you people tell me? All the methods, there is one thing common here. What is it? There's a new keyword. What is it? You know, the reason why I ask you people questions is you will remember it for a long time. Okay? Yes. Synchronized keyword. Have you noticed it? Hope you people never saw this keyword earlier. Synchronized. You know, this keyword has got something to do with the thread safe concept again. Okay? This keyword, it has got something to do with thread safe concept. Okay? So again, even you'll come to know about this synchronized keyword in the thread programming itself. Okay, you'll find that ArrayList class methods are not synchronized. Only vector class methods are synchronized. And one more thing, I wanted to show you people some methods here, especially this method. You see, mm, yeah, set elemented. You know, this is in the vector class. You know, the collection API, the collection interface, list interface, whatever we're talking about, it was added in later versions of Java. Okay. In the beginning, when Java was introduced, there were only few handful of collection classes, and you see, vector was one such class which was introduced in earlier versions of Java, where we didn't have the collection API, complete API, which we are talking about now. Okay. So you see, you'll find that we got this set elemented method here. Now it was the old method. Now even now you can use it if you want, but you know this method. Can you people tell me it is equal to which method here in the list interface? It is similar to which method in list interface? Set elemented. Yes, that's right, exactly. The same as set method. Set element is same as set method, I can say. Next you got remove elemented. It is same as remove method. You see earlier in the old versions of Java, you see this method names were very lengthy. So that is what you can realize. Next, you know, one more thing. Earlier we didn't had a iterator interface also. In the earlier versions of Java, we didn't even had a iterator. Then, you know, you got this enumeration here. Yes, this is an ancestor to your iterator interface, I can say. This is an ancestor to your iterator interface. Yes. Let me show you the methods of enumeration. This was old interface. Now we got iterator. Sorry. See, enumeration. Prior to iterator, we had enumeration. So enumeration is also used to read the elements, but you'll find that you can only use it for vector. Only for legacy classes it works, like vector stack and all. Yes. So you see, these are the two methods. Has more elements, and the other one is next element. Now, can you people relate these methods to the iterator interface methods? Yes. Has more elements is same as has next method. Next element method is same as next method. Okay. Yes. Okay. You see, I'll show you people. Let's use vector ones. Maybe at some point of time, if you see that enumeration, you should not panic. That is very simple actually. Enumeration is not at all complicated. Yes. You see, now I've changed that collection class name from array list to vector. Still, we can use iterator for vector as well. But you see, let's do this. Now we'll use this method elements. You know, if you want enumeration object reference, you have to call elements method. And this is very, very important. You will easily forget this method name. Okay. Yes. Please make a note of it. What is this method? It helps you people to read. Sorry, it returns the enumeration object reference. Elements method returns enumeration object reference here. Okay. Yes. Yeah. So I'll do this. You see, has more elements is same as has next. So it will check whether there is any element after the cursor. If so, it returns true. And the next element method here, you see, it is used to read the element, same as next method. Yes. So let's run this code. Okay, fine. Next, we'll go through stack. You know, stack is a subclass of vector. Stack extends vector. Stack data structure, most of you people might be knowing this. Stack works like this, you know. The elements are placed one on top of the other. You will find that the first element which is added will be the last element to be removed from the stack. First in, last out. First in, last out. The first element which you read, sorry, first element which we add to the stack will be the last element to be removed. First element which is added to the stack, it will be the last element to be removed. First in, last out. So let's check this once. Just a minute. You see, this is your stack data structure. The elements are placed one on top of the other. Okay, you'll find that in the stack, you see the first element which is added at the bottom of the stack, and the next element will be placed on top of that element 1. Again, the next element will be placed on that element again, element 3. So this is how it works. Okay, yes. So you see the last element which is added is on the top of the stack. The last element which is added here is at the top of the stack here. Yes. We got some terminology which is used basically. You know, um, the element, you see, not only terminology, but there is one thing special about the stack. You will find that always the elements to the stack, they are added from one end, that is from the top of the stack. Okay, adding the elements or removing the elements from the stack is done from the top of the stack here. Okay, so you know the terminology which we use here is this: adding an element to the stack. Okay, adding the element to the top of the stack, it is actually called as push. Removing the element from the top of the stack, okay, removing the element from the top of the stack is called as pop, and reading the element which is on the top of the stack is called as peek. Reading the element which is on the top of the stack is called as peek. Okay, so adding the element is called as push. The two, all these operations we do it on the top of the stack. Adding the element is called as push. Reading the element is called as peek. Removing the element from the top of the stack is called as pop. Okay, yes. So here you see the stack class. It is also in the util package. As I told you people, all the collection classes you'll find that they're part of your util package itself. All the collection classes, they are part of your util package. You see, uh, here the stack, it extends vector. As I told you people, stack is a subclass of vector class. Stack is actually the subclass of vector class here. Okay, yes. Stack is a subclass of vector, and you see in the stack class we got this methods: push, pop, peek, empty, search. Push to add an element, pop to remove the element from the top of the stack, peek to read the element which is on the top of the stack. Okay, peek is used to read the element which is on the top of the stack. Empty to check whether the stack is empty or not. If the stack is empty, this method returns true, otherwise it returns false. Now you see here we got a search method also to search an element. Okay, we got a search method to search an element. Yes. You know, what is the difference between the search method which you got here and the search method which you got in the collection interface? Actually, we got a method to search for an element, but that method name is not search. But you know that there is a method in the collection interface to search for the element, right? What is that method? We got a method to search for an element in the collection interface. What is that method? Come on, yeah, you people forgot so soon. Searching an element. To search an element in the collection, we got a method, right? Contains. Yes. So contains method is used to search for an element. Now, what is the difference between this search method and contains method here? Both will search for the element, of course. Both the methods will take an element, it will search for them. Then what is the difference? Yeah, the return value. You will find that the contains method returns true if the element is found, whereas the search method here, if it finds an element, it returns the index of that element. Search method here in the stack, if it finds the element, what it does, it returns the index of that element. That is the difference. Hope this is clear for you people. So this is about stack. Yes. Okay, hope you people are good. Let's move on. Now we'll talk about another collection class in the list here, which implements list interface. What is this linked list class? Okay, linked list class. So linked list class here, it implements a data structure. So what is the data structure? Let's see. Linked list class. Linked list is a class here, our Java class. It implements double linked list, I can say. Double linked list data structure. Yes. It implements double linked list data structure, or doubly linked list, I can say. Yes. Okay. So doubly linked list data structure. This is something special. Let's see. Okay. So hope you people are good to go without a break, right? Uh, at least let me complete this linked list. Then we'll think about the break. Yeah. So are you people good? Shall I? After this, we'll take a break. Okay. Can I have yes or no? Okay. Good. So, okay. I hope others are also fine. Just let me talk about this linked list data structure. Doubly linked list, not even linked list. Again, you'll find that there are different types. This is doubly linked list. You'll find that the doubly linked data structure, in the doubly linked data structure, you'll have node. You know, each node will have three parts. Number one is previous Number 2 is data. Number 3 is next part. Every node has got, each node will have 3 parts. Okay, yes. See the node here, it is divided into 3 parts. You'll have nodes. In the linked list, you may have several nodes. It depends on the number of elements. Each node is divided this way into 3 parts. Previous, data, and the next part here. That's it. Okay, this is a node. So in the linked list, you'll have several such nodes. Now here, the first node always in the doubly linked list, the first node, it will be always null. The data node, sorry, the data part of the node, the the previous part of the node will be null. The data part of the node will have the data, actually you'll have that element here. Okay, so the elements which you're talking about, the actual data will be here in the data part. The next part of the node, here, it refers to the next node, I can say. The next part of the node, it refers to the next node. That is how it works. You see, here the previous part of the second node, it will hold the reference to the first node here. Okay, it holds the reference to the first node. And you see, the second node, again the data part will have an element, and the second node's next part will be having the reference to the third node, and the previous part of the third node will hold the reference to the second node here, and the last node's next part will be null always. This is doubly linked list. Okay, yes, the first node will have a reference to the second node. Okay, always you can say that every node apart from first and last nodes, each node will have a reference to each other. Okay, yes, so the first node will have a reference to the next node, as well as there is no previous node for the first node. So first node will have reference to the second node will have reference to the first node as well as third node. Okay, second node will have reference to the first node as well as the third node here. Yes. Okay, and you see the third node. Let's say if it is not the last node, then it will have reference to the second node as well as the fourth node. Okay, so this is how doubly linked list works. You'll find that doubly linked list, it only supports sequential access. It only supports sequential access here. Okay, it only supports sequential access. Yeah, sequential access means, can you people tell me? I said array list supports random access, whereas doubly linked list, it supports sequential access. What does that mean? Sequential access means access elements in the order. Okay, yes. For suppose if you want to access the third element, sorry, third node which you got here. If you want to access the third node, you will find that you need to access the second node first. You need to access the second node first. And in order to access the second node, you have to access the first node. Why so? Because you see, the reference to the third node, you'll find that you have it in second node. The reference to the third node, you have it in the reference of the third node is stored in the second node, and the reference to the second node is stored in the first node. So that's the reason why you have to start from the beginning. Okay, yes. So you see, the elements, you have to access them sequentially always. Only sequential access is possible here. Only sequential access is possible here. So in order to access the second node, now you have to access the first node. Or in order to access the third node, you need to access two nodes before the third node. All the nodes before the third node, you have to access them. That is how it works. And for suppose here, let's say you got let's say 100 nodes. Just assume, let's say you got 100 nodes. Now in order to access the 100th node, how many nodes do we need to access here? To access 100th node, how many nodes are we supposed to access? 99. All the nodes before 100th node. Yes, that's right. Okay, fine. Now if you compare these two data structures, the array list and linked list data structure, if you compare these two data structures, which one will provide you faster search? Searching will be fast in which data structure? Search operation is fast in which data structure? Or reading the elements, I'm sorry. Let's say array list. Reading the elements of the array list will be faster compared to linked list. Okay. But there is an advantage for linked list as well. What is it? For suppose if you want to add the element somewhere in the middle of the collection, if you want to add an element somewhere in the middle of the collection, in that case we will not have an overhead of moving the elements. In case of linked list, there won't be any overhead of moving the elements in the linked list, I can say. Okay, yes, will not have overhead. There won't be any overhead of moving the elements in linked list. Yes. How? I'll tell you. For suppose, just imagine in this linked list you have 100 nodes. Just imagine, assume that you got 100 nodes in this linked list. In that case, I would like to add a node at index 1. That means after the first node at index 1 I want to add a new node. What to do? So this will be very simple here. You see, all you need to do is just create a new node and change the references of that existing nodes here. You see, now the existing first node, next part should be referring to the new node which you want to add, and the existing second node should be second node's previous part should be referring to the new node again. So existing first node's next part should be referring to this new node, and existing second node previous part should be referring to the new node. And you see, the new node's previous part should be referring to the first node, new node's previous part should be referring to the first node, and new node's next part should be referring to the existing second node. That's it. You see, So this is how it works. Do we have an overhead of moving the elements here in case of adding the elements in the middle of the collection? There's no overhead of moving the elements, right? Just a minute, please. Yeah, sorry. So hope you people understood this. There is no overhead of moving the elements in case of linked list, right? That means if you got a requirement where you need to add the elements somewhere in the middle of the collection, okay? If you have to add the elements in the middle of the collection, in that case, you can go for this linked list because we don't have an overhead of moving the elements in case of linked list, right? In case of doubly linked list, we have that. Sorry, in case of array list, we have that issue of or overhead of moving the elements. Yeah, is it clear for you people, all of you? Okay, good. Just a minute, please. Just a minute. I'm sorry. Okay, fine. So this is about your various data structures, list type especially. Now I have a question for you people. So this is important. Now what if I want to sort the elements which you got here? What if I want to sort the elements? Then what? What to do? You know, we got a method which helps us. Actually, we have to use a class for that. It is actually called as collections class. There is a class. Don't mistaken it with the collection interface. Collection interface is different and collections class is different. Okay, here in the collections class, we got a method called as sort. So to this sort method, you can pass this collection object reference. You see, I'm passing that collection object reference. Now what the sort method does, sort method now, it will rearrange the elements based on the nature of that elements. It will sort them. It will sort them based on the nature of the elements. It will sort them based on the nature of the elements. Now, what is the natural order of the strings? Natural order of the strings is lexicographical order, or we say dictionary order. Okay. Now that sort method will take that collection object reference, which it will sort the elements based on that dictionary order or lexicographical order, and it will store them into that collection itself. Okay, it will rearrange the elements, sort. It will sort them. That's it. Now you see, if I read the elements here, so it should display them in that dictionary order. Okay, now you see the order has changed here, right? Yes. So I hope you people got it. Yeah. So sort method is doing this. But you know, it was very simple and straightforward in case of strings, but that won't be the case for other type of elements. Okay. Yes. So far we are working with strings, right? But for suppose we have some other type of objects here. The elements are different type, not string type. Let's say the elements are product object type. Let me add product objects here as elements. Okay. So I'll create a vector, or you can create any class, collection class. Okay, that won't be an issue. So here, you see, I have to specify what type of elements I want to store here into the collection. And you see, how do we specify what type of elements you want to store? How will you specify? You see, we are going to use this angular brackets for that. In the angular brackets, we are specifying the type of element. Here in this case, we have mentioned it as product. Yes. Now, to add the elements, you know, we use add method here, and you can directly pass this product objects. Yes. See, say we'll add these elements. Now we got 4 elements. Now I want to sort the elements here. What to do? So can we use sort method here? Can we use sort method? See, if I use sort method this time, it won't work. This time it is not going to work. Why? Because you need to understand the concept of comparing the objects in Java before we study this error. Okay, comparing the objects in Java, there is a standard for that. So okay, in sorting, why I'm talking about comparing the elements, hope you know this. When we talk about sorting the elements, the first step in sorting the elements is comparing the elements, right? Comparing. In order to sort the elements have to be compared first. Based on the comparisons, you know, you'll come to know which element is greater, which element is smaller, and based on that, accordingly, you will sort them. That means you will rearrange the elements accordingly. Okay, comparing the elements is an integral part of your sorting. Without comparing the elements, we cannot sort the elements, right? Yes. So you see, we are using the sort method to sort the elements. The actual logic for comparing the objects, okay, or comparing the elements, you will find that it is not defined in the sort method. In the sort method, the logic for comparing the objects is not defined. Then you have only the code to rearrange the elements, but comparing the elements, the sort method is going to take the help of the method, okay, uh, which has to be provided by that objects itself which you're trying to compare. You know, in Java, a class, I can say that it is responsible for providing the comparison code as well. The class is responsible for providing the comparison logic for comparing the objects. Yes. And one more thing, the class, how it is going to provide the comparison logic, that is also important. There is a standard for that. So you see, earlier we have gone through the equals method, right? And in order to write the logic to check whether two objects are equal or not, we use equals method, right? Always in the equals method, we write the logic to compare two objects. That means not comparison in sense. Yeah, it is comparison, but we'll only check whether two objects are equal or not. In the equals method, we have written the code to check whether two objects are equal or not. And always we use equals method to write the logic to compare or to check whether two objects are equal or not. To check whether two objects are equal or not, we use equals method. Similarly, to write the comparison logic, okay, to compare the objects, to write the comparison logic, we use a separate interface here called as comparable, and this interface has got a method called as compare to, which you need to override. And in this compare to method itself, you're supposed to write the logic to compare the objects. Okay, so always you're supposed to use this compare to method to write the logic. to compare the objects of a particular class or of a particular type, I can say. Yes. Now the class, if it wants to provide the comparison logic to compare the objects of that particular class, then it has to implement this comparable interface, override the compare to method, and then implement that logic to compare that, implement that logic in this compare to method. Yes. You know, string class exactly does that. You know, string class, it is predefined, right? String class is predefined. So in that class, you have got this compare to method here. You'll find this compare to method, you see, in the string class, you have this method. And in that compare to method, you got the logic to compare the string objects. And compare to method, it is part of your interface, as I told you people. It is part of your interface. Which interface? Comparable. Okay, comparable interface. So string class implements that comparable interface. You see java.lang.comparable. So comparable interface is in java.lang package. Yes, fine. You got this method. You know, the sort method, what it is doing here internally. So when earlier we have used sort method to sort the string objects, right? So in that case, you know, the sort method was internally calling that compare to method to compare the string objects. It was calling sort method definitely uses compare to method of the string class. So when it is comparing the string objects. Okay, yes. Based on this discussion, I can say that in Java, we can classify the objects into two types again. Objects which are comparable and objects which are not comparable. When I say objects are comparable, that means definitely the class to which this object belongs to, that class implements comparable interface and provides the comparison logic through that compare to method. And if I say the objects are not comparable, that means the class to which this object belongs to, that class, it doesn't implement comparable interface and it is not providing the comparison logic through the compare to method. Okay. This way we can broadly classify the objects into two types. Yes, in Java, comparable and non-comparable, or which are not comparable. Objects which are not comparable. Okay, fine. So now can you people tell me the product class product objects, are they comparable or not? The product objects, are they comparable or not? Yes. No. No? Yes, that's right. So you people are right. So the product objects are not comparable. Why? Because you see, the product class is not implementing comparable interface and it is not overriding the compare to method and supplying that comparison logic. Okay, fine. Now very simple question, the second question here. If the objects are not comparable, in that case, can we sort those objects? If the objects are not comparable, is it possible to sort those objects? Can we sort them or can we sort those elements? If the objects are not comparable, then it is highly impossible to sort those elements. Okay, sorting cannot be done. So always sorting will be done based on the comparisons itself. So sorting the elements means arranging the elements in an order, which element is greater, which element is smaller, right? So in that order you'll be sorting. You'll be arranging the elements. But if you don't know which element is smaller, which element is greater, so how will you arrange them? It won't be possible. So product objects are not comparable. You know, that's the reason why the sort method, it it throws that error. You know, yes, to make you people understand that error, I have to tell you all this. But not only that, but definitely you should know this. Yes. So this is one of the important concepts in Java. You see, you will be creating objects, and you should make sure that the objects are comparable as well. So if needed, you have to do that. Yes. So you see, the sort method, it is not taking that collection object reference which holds product objects. Why so? It says this objects, okay, the elements which are stored in this collection, they are not comparable. The error says the elements which are stored in this collection, they are not comparable, so it is not possible to sort them. So it is not taking it. That's it. Yes. So hope you people got it. So any doubts or issues in this regard, please let me know. Any questions? Okay. Okay, good. Now I guess now you may have one question here. How do we make this product objects comparable? How do we make this product objects comparable? By this time, hope you also understood this, right? How to make the product objects comparable. So what are we supposed to do now? I would like to make this product objects comparable so that sort method can arrange these elements in an order. Yes, what to do? Sort method should rearrange these elements. I want the sort method to do that. But first of all, for that, I have to make this product objects comparable. So what to do? How can we make product objects comparable? Very good, that's right, exactly. So product class must implement the comparable interface here. You make the product class implements comparable interface, and you have to mention here product type and override the compare to method. Yes, exactly. You see the way we have overridden equals method earlier. Similarly, now we have to override compare method. But before we override this method, first of all, let me explain you people the usage of this method, how we are going to use this method. Okay, how this method will be invoked and how it will be used. Let's see the usage. So let's say for suppose you have two product objects, product 1 and product 2. Now if you want to compare these two objects, now you can use compare to method. Let's assume that it is overridden. So you have to use one of the object references to call this method compare to, and the other object reference you have to explicitly pass it to this method here. You have to explicitly pass it to this method. That's it. Okay. Now compare to method, you know what it does? If it returns an integer value always. Compare to method always returns integer value. See, the return type of the compare to method is integer type. So if p1 if p1 is greater than p2, then you know it returns 1. Compare to method should return 1. If p1 is less than p2, compare to method should return -1. If both are equal, if p1 and p2 both are equal, then it should return 0. That's it. It should return 0. Got it? So these are the three possible values the compare to method should return. If p1 is greater than p2, it should return 1. If p1 is less than p2, it should return -1. If p1 and p2 are equal, it should return 0. Yes. So keeping in this mind, okay, keep this in mind and try to override the method. So now you see one of the object reference, the first object reference will be used to call this method, right? So that object reference, it is implicitly passed, it is stored in this variable. It will be stored in this variable. You can obtain that object reference. And the second object reference is explicitly passed, it is stored in this variable, product 2. Now let's compare them. Now one more question. On what basis you are going to compare the objects? Based on the ID, name, description, price? Now this you will not decide it, your clients will decide it. Your clients may give you the requirements. I want to display the records, based on the name, based on the ID, based on the price. Got it? Let's say in this case we'll go for IDs. Okay, we'll go for IDs. So product one dot get ID, if it is greater than product two dot ID, then we have to return one. This method should return one. Else if product one dot ID, if it is less than second product's ID, say will return minus one. And see if these two conditions fail, I can say both the product IDs are equal. So in that case, we'll return 0 here. That's it. Okay, it returns 0. Now we have made product objects comparable, I can say. We have made product objects comparable. So because the product objects are comparable, now they are eligible for sorting. So when you call the sort method and pass the product objects reference, that collection object reference, you see it won't throw any error this time. It is taking it, sort method is taking it here. Now sort method, what it does internally, it uses this compare to method to compare two elements at a time. At a time it will compare two elements. You may have 100 elements, but still at a time it compares two elements, always. Okay, yes, fine. Now after sorting, let me just read these elements from the collection using a for each loop. We'll try to do that. Okay, I'll just read the IDs and the names. Okay, that's it. We'll read the IDs and names. Okay, we'll run this code. Okay, are the elements sorted? You can just check this. So in which order did we add the elements? In which order did we add the elements? The first element was 102, then 103, 104, 101. Now you see the order in which the elements are displayed here. It is in the ascending order of the product IDs, right? Product ID ascending order. That means the elements have been sorted. Yes. So is this clear for you people? Can I have yes, no? Okay, good. So this is very important. So just try to go through this comparable interface. Okay. Yes. So when we talk about comparisons, we got another interface. This comparable interface, as I told you people, it is in java.lang package. Please make a note of it. But you will find that we got another interface called as comparator. Comparator. It is in a util package, and in this interface also we got a method called as compare. But I'll tell you people when we are going to use it. We'll discuss about it later. But if you got some time, meanwhile you can go through it. Okay, you can just check this method, this interface once, comparator interface, how to use it. Okay, you check that. I'll give you a requirement in the next class. We'll see that. Yes, fine. So far whatever we have discussed today, right from the beginning of the session. So we have started with the iterative interface, then list, then array list, linked list, then vector stack, and then lastly sorting and comparable interface. Hope all these things are clear for you people. So if you got any questions, just ask me. Yes. No? Okay. So I'll stop it here then. So we'll meet. Okay, I'll tell you. This Sunday weekend, we got a class at 6 p.m. Central Time. Please make a note of it. It can be 1.5 hour to 2 hour session, and I'm going to talk about JUnit here. JUnit, a testing framework. Okay, this is a special class on Sunday at 6 p.m. Central Time. Please do attend this class. I'll mail you people again. So this class is a JUnit class, and the meeting link for this class will be different. Okay, I'm going to merge you people with another batch. So I'm taking the class for a couple of batches. So you will be merged with another batch. For this class, the meeting link is going to change. Okay, yes, only for this particular class on Sunday evening. Yeah. So JUnit class, just take this class. It's unit testing framework. Yes. Okay. So I'll stop it here.